Hello, this is Mike here from the Math Center at Grantham. And occasionally I get students who are asked to use a graphing utility to integrate a function. Some students are deployed. They don't have a graphing calculator and can't really get one while they're deployed. So I'm going to show you a program that you can download called GeoGebra here in a minute. Um, and with this math graphing program, among the things you can do with it is do this kind of numerical graphing integration. So the problem itself here that we're going to look at is to integrate the function 1 over 1 minus t, and to do that from 0 to 1 half. So I'm going to go over here to GeoGebra program. This is a free program available at www.geogebra.org. It does require Java. So if you don't have Java installed, it'll let you know, and you'll have to download a Java client on your machine. It'll work with Windows and Mac. Um, there's also an Android version of it that doesn't quite have the same functionality, but there is if for Google Chrome on your desktops too, there is a Chrome web app in the Chrome store. It has most of the functionality of the full version, but not all of the functionality. So if you want to try that first, you can. If you run into any limitations, you'll have to download the full program. So what I'm going to do here is, first of all, um, I've got three windows open: the algebra, graphics, and construction protocol window. I'll close that construction protocol window down. We really don't need that. And this isn't a full tutorial on the program, just kind of tells you how to do something very quick and easy. So I'm going to say, first of all, the problem uh, is to integrate the function 1 over 1 minus t, but we have to make that 1 over 1 minus x in this program. Now I'm going to call this function f, and I'm saying f colon equals. The colon equal means I'm basically making a function assignment, or assigning a specific variable to the function. And I'm going to go 1 divided by left parentheses 1 minus x. And when I press enter, I get the function. Up here it pre-prints the function in almost a textbook format, so we can make sure that we compare it to what we have over here, and yeah, this looks right, only we have x instead of t. Now let's recall that, well, first of all, this is just kind of an aside, but we can see what looks like an asymptote here at x equals 1. And if we wanted to kind of graphically confirm that, we can actually go down here and plot x equals 1. X equals 1 will plot a vertical line right at x equals 1. A lot of graphing programs, math graphing programs, won't do this kind of graph, but GeoGebra does it very nicely. And I'm going to change this to a dashed line. And if we zoom out, I'm using the mouse wheel to zoom out. This is a little, you can change the center of the view there. We can see, yeah, that looks about right. But it's not really going to affect us here because we're asked to integrate that from the x values from 0 to 1 half. And remember that the integral of a function is represented graphically by the area between the x-axis and the curve itself. Now, this is very simple to do here in this program. Just go back down to the input line, start typing in the word integral. Now notice it'll start, this is command line completion for you. It has several ways that you can input this function, and we're going to have a start value and an end value, so I'm going to select integral with 3 arguments: function, start value, and end value. I'm going to hit enter, and notice it immediately highlights the function area. So I'm just type in f because that's the name of our function up here at the top. Then I'm going to hit tab. It'll go to start value, and I want to start at 0, and I want to end at 1 half. You can input that as 0.5 or 1 half, it doesn't matter. And I press enter, and look what we have here. We have a nice little picture. It shows the area between, and I'm going to hit this little arrow over here so I can move this out of the grayed out area to see the number better. We have the area under the curve, or between the curve and the x-axis, and the program calculates the area. So this 0.69 here is the area. If you want more precision on that, you go up to options and rounding, and you go up to like 15 decimal places if you want that many. And there you have it. We have used a graphing utility to integrate the function. I hope you. Oh, and once you get to this point, say you need to include this in your document, maybe a document you're posting in your Dropbox or emailing to the instructor, you can go up here and select Edit and Graphic View to Clipboard. Then go right back over into Word, right click and paste, and it gives you a little picture. And if it's a little too big, you can resize it, whatever, and submit that with the rest of your homework. I hope you found this useful, and if you have any questions, you can email us at mathcenter@grantham.edu. Thank you.